all. This video is all about Internet of Things and the connectivity in Industrial Internet of Things. So here we are going to learn about the protocols, the communication protocols which are necessary uh, for two devices to communicate with each other. The following communication protocols are important for Internet of Things. These protocols, of course, we have to remember. Bluetooth, we know. Radio frequency identification, we know. NFC, ISA 100, Z-Wave, Zigbee, wireless HART, IEEE 802.15.4. So these are the low PAN. So these are the these are the communication protocols which are usually used in Internet of Things. So the first one which we are going to learn here is IEEE 802.15.4. So this standard usually provides a framework which is meant for lower layers, MAC, and the physical layer for wireless personal area network. So WAN is nothing but wireless personal area network, usually uses IEEE communication protocol. So the physical layer usually defines the frequency band in which the signal has to travel, the transmission power which is necessary for the signal to travel from the input device to the output device, the modulation scheme. So which type of modulation we are using. Uh, so all these three things, the frequency band, the transmission power, and the modulation schemes are defined in the physical layer. Modulation is nothing but removing the extra noise or the distortion in the main signal, in the transmission signal. So that is what we say it as modulation scheme. So this MAC defines issues such as a medium access and the flow control frames. When we are sending the data from the input signal to the output signal, the data, it cannot transfer or it cannot send as such directly. What happens? The data will be transmitted in the form of frames and packets, one by one. So one packet will be in the form of series or in the form of serial data bit. That is what we say it as serial data bit. So data will be transferred in the form of frames. This standard is used for low power, low cost manufacturing and operation and low speed communication between the neighboring devices. So if the devices which are communicating are in the near distance, then this type of IEEE communication protocol can be used. This is less power consuming, low cost, cost efficient, and of course low speed also. So the main features of IEEE 802.15.4, this standard uses direct sequence spread spectrum coding scheme to transmit the information. Phase shift keying modulation is used to encode the data. When we are sending the data through a channel, it cannot be sent as such. We have to encode the data, which means we are converting the data from one form to unreadable form in the transmitter side, and then we have to send the data. We have to convert the data from the unreadable form to the readable form in the receiver side, which is nothing but decoding operation. So binary phase shift keying uses frequency of 868.915 megahertz. Data transmission rate will be 20 or 40 kbps, kilobits per second. OQ PSK 2.4 gigahertz data transmission rate, and the data transmission rate will be around 250 kbps. DSSS scheme makes the standard higher, highly tolerant to noise and interference. So this direct sequence spread spectrum reduces the noise to the maximum and thereby improving the link reliability. So the other features of IEEE communication protocol are the preferable nature of transmission is line of sight. that is transmission of data. The range of transmission can be only up to 10 to 75 meters. Of course, BPSK is used to reduce the noise and distortion. Duty cycle, we have networking. Star network topology has been used. Peer-to-peer network topology can also be used. I hope you would have learned from this video. See you in the next video. Until then, it's bye from Radhika.